this lecture, we're going to talk about how to use Node.js's cluster module to spread the work of your application across all the CPUs available on whatever system you're running on. Doing that is going to make some major changes to the way index.js works. So I'm actually going to create an alternative index.js again, and I'm going to call this one index-cluster.js. So I'm going to copy index.js to index-cluster.js. And now we'll make the modifications to this new file. And when we start it up, we'll start it with this one. In order to use the cluster module properly, we actually need to require two new modules, cluster and OS. OS is something we've used before to get information about the underlying CPU resources, and we're going to use that again to let us know how much of a cluster we can build. So let's require cluster equals require cluster, and let's require OS, which equals require OS. When you start up your app on multiple cores, it is the same thing as starting multiple versions of your app. So there's certain things we don't want to be running multiple times. Even though we're spreading this application across multiple cores, we don't want our CLI to be running across multiple cores. We don't need to give inputs to 4 different CLIs if we're running on a 4-core system. Similarly, we don't want our workers to run 4 times as much. We set our workers to run at the interval that we thought was appropriate. We don't want those to run any faster, so starting 4 of them on a 4-core system would actually get 4 times as many workers running, so 4 times as much stuff happening as we intended. Instead, the only thing we really want spread across all of our cores is what our server is doing, which is taking in requests. As the server takes in requests, we want the load to be spread across as many cores as possible, so as many HTTP requests can be processed per minute as our whole system resources will allow. So I'm just going to reorganize this section here a little bit. I'm going to move the CLI and the workers to the top of this init function, and I'm going to put the server at the bottom. So when Node starts up, it's going to start up in the normal way. And that first thread that starts is what the cluster module is going to call master. Everything else that the cluster module creates, all the other threads, are going to be called forks. We're forking the process to another core of the CPU. So we need to write logic in here that can tell if I am the master, I need to perform this behavior. If I am one of the forked clusters, I should perform some other behavior. So what we're going to say is that the workers and the CLI should start on the master thread. And then all these other forks that get created, all these other threads, those should be the ones that start up the server, which is why I moved it down here. So the first thing we're going to say is if cluster is master, then we want to do these 2 things here. So I'm going to paste these inside of this if. So these will get started on this first master thread that gets started up when you boot up the application. But then I'm going to put in an else, and here we're going to paste in server.init. And server.init is actually going to start the HTTP server. So I'm going to change this comment to say if we're not on the master thread, start the HTTP server. Up here, I'm going to say, if we're on the master thread, start the background workers and the CLI. Now, the changes we've made so far aren't going to work because we haven't actually forked this thread, the master thread, at all, and so this else is never going to get called. There isn't ever going to be a fork started. So we have to manually fork this process when it's in master mode. So we're going to say fork the process, and for that we're going to call a for loop. And we're going to cycle through this for loop the same number of times as the number of cores on the CPU. That is where the OS module comes in. So we're going to say for var I equals 0, I is less than os.cpus. length. Remember, OS CPUs returns an array with information about all the CPUs. So getting the length of that array gives you the number of CPUs in the system. This is similar to what we did in the stats module. Then we're going to call I++. So this for loop is going to get called once for each of the number of CPUs in the system. And so for each of the CPUs, we're going to call cluster.fork. As this gets called, this is going to start the app up again and call this primary file or entry file again. But when it gets called the second time, it's going to be a fork, and it will know that it's a fork. So when it hits cluster is master, this will not be truthy, and you'll end up in the else, where all it will do is start this server.init. You can see this in effect if we start this up, because of the logging that we have in place for the different parts of the system. So if I start the app up the normal way with index.js, we can see background workers are running, servers listening, CLI is running. What if I started up with this new file we created, node index-cluster.js? Background workers are running, the CLI is running, and now we actually have 4 of each type of server log. The server is listening on 3000, again, 3001, again. You might be thinking, how can these different threads all listen on the same port without having a port conflict? That is something Node is smart enough to resolve on its own. These different threads are going to share listening on the same port, but as requests come in, they'll be delegated to each of the cores, and they'll each be able to handle some of the load. If we go back to Postman and send a request to this API, we can see it works as normal. We got a 200 back, we're able to create a token, and the API is functioning as normal, except that all these cores are running. The one issue with this is being able to test or create tests or create a test runner when your API is taking over all the cores can be somewhat tricky. And so if you're going to implement it, if you have a good reason to implement cluster module, and you have some good functionality that you want to push over to different forks, to different CPUs, go ahead and do it, but be prepared to refactor the way that you're testing. So with that, we can kill this and move on to the next lecture.